Good day. Welcome to Sam's online class. So, we are focusing on substitution in logarithm today. So, we are looking at substitution in logarithm. How does substitution in logarithm works? In substitution in logarithm, certain values, at times it might be a number, at times it might be an expression, and at times it might just be an alphabet, will be given to replace certain logarithm value after the logarithm value have been simplified. So that is logarithm substitution or substitution in logarithm. So we'll be looking at how we can first break down the logarithm value given into the values we are expected to use to substitute. Then afterwards, we change the values, the values to be substituted to the new values. Then we get the answer to the question. So I have an example here that given that x is equal to log 2 and y is equal to log 3, express log cube root of 72 in terms of x and y. So the question wants log cube root of 72. We want to express that in terms of x and y. So here we are changing all of log 2, any log 2 that we have, to y, to x, and any log 3 that we have to y. So we first need to break 72 down into a group of numbers with 2 and 3. Then we can then do our substitution. So, but I will first deal with the root here. The root of 72. I explained in our last class that a fraction, indices, when it takes a fractional power, well, any number takes a fractional power. This is the law of indices. The root, the denominator of the power becomes the root. N here will become the root. So if it is 2 that is n, this will become square root. If it is 3 that is n, the root will be cube root. So we then have y the numerator will be the power. So 72 have a root here. 72 has cube root. If we express it, there's no power for 72. So that means the power is 1. So let's say 1 here. If we express it in terms of fractional power, we have 72. The denominator, so I will have a fraction as the power. The denominator is always the root. So since we have cube root here, that means the denominator will be 3. Then we have 1. Because the power of 72 here, since there is no power, that means the power is 1. So we have log cube root of 72 is the same thing as 72 to the power of 1 over 3. So we can take the power to the coefficient. It's one of the laws of logarithm. We had the law of this nature that if we have log x m raised to power n is equal to n log m base x. So if we apply that, we can have 1 over 3 log 72. So I will change 72. I will simplify 72 till I have a set of 2 and 3, multiples of 2 and 3 that multiplies, that will give 72 when multiplied. So if I start with 8 times 9, 8 times 9 will give 72. Then I can further break 8 and 9. I can further break them down to 2 raised to power 3. 8 is 2 raised to power 3, while 9 is 3 raised to power 2. So I have this. The first law, then from here we apply the first law of logarithm. Remind us of the law. The first law of logarithm, we have log m times n can be expressed as log m plus log n as far as the bases are the same. So we can do this when the bases are the same. There's no base here, and I said it when we don't have any base, it means the logarithm is in a standard base, which is base 10. So we have this here. Let me use a bracket at this point because this will become two different logs. So I have log 2 raised to power 3 plus log 3 raised to power 2. Then I close brackets. So from here I have 1 over 3 log. I can apply the same law I applied to the power of 72 here, that is power becomes coefficient. So I will have 3 log 2 plus 2 log 3. So log 3. So from here, we can go ahead and do our substitution. Okay, let's go ahead and do our substitution. Let's look at the values we are substituting. Now from the question, log 2 will be replaced with x and log 3 will be replaced with y. That means we have 1 over 3 in brackets. This is x, so it will be, instead of the log 2 we have x, so it will be 3x plus, instead of the log 3 we have y, so it will be 2y. So this is what we have, and we can simplify the answer further as 3x plus 2y all divided by 3, which can also be 3x over 3 plus 2y over 3. So if we simplify this and this, we have x plus 2y over 3. Expressing your answer as either of these 3 will be absolutely correct. So that is the first example. We'll move ahead to the second. We'll move ahead to the second. This is a 1988 question. So if we have log 2 base 10 is equal to 0.3010 and log 3 base 10 is equal to 0.4771. Evaluate without using tables. Log 4.5 base 10. So we might have to think, how do we express 4.5 in terms of 2 and 3? So let's look at it. So we have log 4.5 base 10. The first thing we have to look at is that we can express 4.5 in this form as 45 over 10. 45 over 10. So we have 4.5 as 45 over 10. Now from here, we can apply the second law, the law that has to do with division, which says if we have log base x m over n, it can be expressed as log m base x minus log n base x. As far as the bases are the same, division turns to subtraction. So from here, if I apply that, I have log 45 base 10 minus log 10 base 10. So from here, I can now break down 45 it's a number in terms of just break it down. In terms of 3, let's say 3 and 5, majorly 3 and 5. So if I first break it down to 9 times 5 in a bracket, because 9 times 5 is equal to 45, then I have log 10 base 10. Then I can further break it down to 3 raised to power 2 times 5 minus log 10 base 10. So from here I can apply the first law, where multiplication turns to addition. So I have log base 10 3 raised to power 2 times log 5 base 10 minus log 10 base 10. So we were given in our substitution, the values given for us to substitute. We were given log 10 base 5. We're only given log 10 base 2 and log 2 base 10, and log 3 base 10. We weren't given log 5 base 10. So that means we need to find another way to simplify log 5 base 10. And the best way we can do that is to change 5 to 10 divided by 2. 10 divided by 2. So we keep breaking them down to suit the values we want to use to substitute. Else we wouldn't be able to substitute. So if I do that, I have log 3 square base 10. Okay, there's a mistake somewhere. Let's correct that. This should be addition. We have changed the logarithm, so we should have addition here. We have applied second law to this. So it should be addition after we apply second law, not multiplication. So from there, I'm changing log 5 to 10 over 2 minus log 10 base 10. So from here, we have, I can take the power here to coefficient. That will be 2 log 10, 2 log 3 base 10. Then I can apply second law to this, where division turns to subtraction. I have log 10 base 10 minus log 2 base 10. Then I close the bracket before minus log 10. So I will use this addition to open up those brackets here. So I have 2 log 3 base 10 plus log 10 base 10 minus log 2 base 10 minus log 10 base 10. So these two can take out each other. One is positive, one is negative. Log 10 base 10 minus log 10 base 10. So they can take out each other. So from there, we have 2 log 3 base 10 minus log 2 base 10. So we're giving the values 0.3010 to substitute for log 2 base 10 and 0.4771 to substitute for log 3 base 10. So here we have 2 in bracket, 0.4771 771 minus 0.3010. So we have substituted, we have changed log 2 to 0.3010 and log 3 to 0.4771. So if we multiply, then you apply your calculator for me. We'll multiply. So we are doing 2 in bracket 0.4771, close the bracket, minus 0.3010. Then we have this as our answer, 0.6532. Now to confirm if your answer is right or wrong, if you go ahead to press this on your calculator, log 4.5 base 10, you should get either the same answer or something close. Log, because that was what we simplified initially. Log base 10, base 10, then 4.5. So 0.65321. So we're absolutely correct. We move to the next example. So we have here given that log 7 base 10 is x, log 7 base 10 is x, and log 2 base 10 is y. Evaluate without using table log 35 base 10. So we're finding logarithm of 35 base 10. So from here, we'll break 35 down to possible. Break 35 down. The best simplification you can give to 35 is 5 times 7. We apply first law to this. Multiplication turns to addition. We have log 5 base 10 plus log 7 base 10. So we were not giving any number to substitute for log 5 base 10. So let it be. We just break it down further to 10 and 2. 10 over 2 is the same thing as 5, just like we did in the last question. So it will be 10 over 2 replacing 5. Then we have base 10 plus log 7 base 10. So from here, we will apply second law where division turns to subtraction. That is log 10 base 10 minus log 2 base 10. Log 2 base 10 plus log 7 base 10. So we can go ahead to do our substitution now. So from what we have, 1 log 10 base 10, when the base and the argument are the same, the answer is 1, minus log 2 base 10 is y, then log 7 base 10 is x, so we have plus x. So the answer is, when rearranged, if we want it to be like their own the options they provided, when rearranged, when this is rearranged, I can have x minus y plus 1. X is positive here, x is still positive. The new one we wrote, y is negative, y is still positive. 1 is positive, 1 is still positive. So they are the same. So this is the answer to the question. Quite simple and straightforward. The third example. So given that log, this is not clear. Given that log 2 base a is 0.693 and log 3 base a is 1.097, find log 13.5 base a. So we have log 13.5 base a. So we change the decimal to fraction. That will be log 135 over 10 base a. From where we can apply second law, that will become log 135 base a minus log 10 base a. So we have this from here. We can break 135 down. Let me use prime factor table to break 135 down. So I have 135. So the number that can divide 135 is 5. Let's start with 5. 5. 5 divide 135. 5 divide 13 is 2. And 3. 5 divide 35 will be 7. Then 3 can divide now. 3 in 27 is 9. 3 in 9 is 3. 3 in 3 is 1. So we have 3 raised to power 3 times 5 as our answer. So we change that. So we have log 3 raised to power 3 times 5 base a minus log 10 base a. So from here we have log, we can apply first law to 3 raised to power 3 times 5. So we have log 3 raised to power 3 base a plus log 5 base a minus log 10 base a. Since we were not giving any number to use to replace log 5, so can go forward thus. Have log 3 raised to power 3 base a. I will change 5 to 10 over 2 log 10 over 2 base a minus log 10 base a. So from here, I can turn power to coefficient. That becomes 3 log 3 base a plus log, let me use a bracket here because we'll be changing to two things. So I have log 10 base a minus log 2 base a, applying second law to this. Apply second law to this, then I have this. So minus log 10 base a. So I have 3 log 3 base a plus log 10 base a minus log 2 base a minus log 10 base a. So from here, this we take out this positive negative. They will take out each other. So we then have log 3 log 3 base a minus log 2 base a. So let's see the values we are meant to use to substitute this. Let's see the values. So we are using 0.693 to replace log 2 base a and 1.097 to replace log 3 base a. So I have 3 in brackets, 1.097 minus 0.693. So if we multiply this, we get the answer. So let's use our calculator. 3 in brackets, 1.097 minus 0.693. So we have these answer 2.598 as our answer. 2.598. So that is the simplification for the answer for the question, and the answer is option C. So we will stop here. Let's look at the things we have done today. We'll stop here. We have done substitution, and we took these examples. So I hope we can substitute in a logarithm expression now. It's very easy and straightforward. Thanks for staying tuned. Please drop your comment, like, and subscribe to the page. And you can contact me. My contacts are in the description of this video, so you can check there to contact me for online mathematics classes. Thank you.